Hi, my name is Jake Riley, and today I will be your teacher on probability. To give you guys kind of a roadmap for our lesson today, this lesson should take anywhere from the realm of 20 to 30 minutes, and it's all going to be very fun and interactive. All you're going to need for today's lesson is a die, a piece of paper, and a pencil, and an open mind. To address some of the issues at the start of this lesson, if I do sound a little bit congested, I'm sorry. I am slightly sick right now, but I'm getting over it. And lastly, I wanted to address our Sunday meeting. I'm so sorry I couldn't be there for you guys to teach, and I'm deeply regretful for that. And I hope that this lesson can kind of serve as an apology. So, kind of to get your brains rolling, to get the dice rolling, let's say, I want to start with this warm up exercise. I want each of you in your mind to think, just think in your mind, you don't have to write it down. How many times on average will it take for every side of a die to appear when rolling it? On average, all 6 sides of the die. Think for a second and then come back to me. So hopefully now all of you guys have came up with a guess in your head for how many rolls it will take before you see every face on a die, 1 through 6, at least once. Now with this guess, you can either keep it in your head if you think you can remember it, or you could write it down on a piece of paper. But this is going to be important because we're about to test the accuracy of this with an experiment, and then look at it through the lens of probability. So to start, I'll give all of you 1 second to grab a paper, a pencil, and a die, or an online die, whatever you have access to at this moment. I'll give all of you 1 second to grab that. So now, hopefully all of you guys have acquired the materials for this experiment, which are a die, a pencil, and a piece of paper. Now you are going to make a table. Now this is going to be a small table with 6 boxes, 1 for each number, 1 through 6. Now to make this more clear to you guys, I'm going to have a table up on the screen for you guys to follow to be more precise. But once you have this table drawn on your piece of paper, you're going to roll the die, either real or online, and each time you get a number, tick its box. Keep rolling until every box has at least 1 tick. Count how many total rolls you use and write that number in big letters at the bottom of the box. Now, if you guys need some more time to do this first step, you could pause the video here. So after completing that step, there's an optional second step to get more accurate results for this experiment. If you want better data, pause the video now again and repeat the whole experiment 2 more times. When you're done, average your 3 totals by adding the amount of total tally marks and dividing it by the amount of trials you do. Welcome back. So now we're going to see how close your average was that you rolled yourself, your experimentally determined average, and we're going to see how close it is to what math predicts. So the way we're going to look at this mathematical prediction is we're going to look at it like each time you roll the die, we're going to be hunting for a new face. And a new face is a 2 or a 3 or a 5, something that hasn't been rolled yet. Something that, there's no repeats, let's say. So on our first roll, we're guaranteed to have a unique face. So it's only going to be 1 roll. Now when searching for the second new face, 5 of the 6 faces on the die are still new. So the chance the very next roll is new is 5 over 6. So the expected number of rolls is 1 divided by 5 over 6, which is 1.2 expected rolls. Now this pattern continues down for all 6 faces. The third new face, for example, is 4 over 6 faces are new. So it's 1 divided by 4 over 6 equals 1.5 rolls. This continues for the 4th new face, the 5th new face, and the 6th new face. So now on the screen, I have the calculations I use to calculate the expected number of rolls to get the first unique face, the second unique face, and the third unique face. Using these calculations, I want you guys to attempt to calculate how many expected rolls it will take to find the 4th new face, the 5th new face, and the 6th new face. I understand this may take a second, so take a second to calculate those values now. And after you calculate those values, add them all up to find the average number of rolls it takes to find all 6 unique faces. Okay, so now hopefully all of you guys have calculated the number of expected rolls for the 4th, 5th, and 6th unique faces, and you've added them all up. I'll put the calculations of adding them all up, which is 1 plus 1.2 plus 1.5 plus 2 plus 3 plus 6 onto the screen now, which equates to an average of 14.7 rolls. So if your experimentally calculated average when you were rolling the die yourself and tallying it was anywhere near 15, great job. Your experiment matched the theory. Okay, so now we've already established some basic principles of probability, and we're going to move into a slightly harder challenge problem. Now this problem is most likely going to trouble you guys a little bit, and it's going to take you guys a second to solve. So I'll leave plenty of time to pause the video, and I'll offer a pretty detailed explanation of it. So the question is, if you roll a die 6 times, what is the chances you'll see at least 1 6? Now think on your own first. Use your pencil, use your paper, jot down your ideas, and when you're ready, hit play again. But you can pause now. Alright, so hopefully you guys have now tried your best to come up with a calculation, and if you haven't, that's 100% okay. This is a harder problem. So here's the trick. It's easier to ask, what are the chances I see no 6s at all in those 6 rolls? And then we'll subtract that from 1 to get our given percent. So I'll be putting all of the math up on the screen now so you guys can see how I did this, but I'll also explain it in my own words. The chance any single roll is not a 6 is 5 out of 6, because there are 6 faces of a die, and there's one of those six faces are a 6. The rolls are independent, so multiply that 6 times. So on your calculator, or on, you can put it into Google as well, you'll have in parentheses 5 divided by 6 to the 6th power. Grab a calculator or estimate, and you get around 0.334, which means there's about a 33% chance of 0 6s. Now subtract this from 1, which is 1 minus 0.334, and that equals 0.66, or roughly 67%. So 2/3 of the time, you'll spot at least 1 6 in 6 rolls. Okay, so now that you got this concept down, I know some of you are looking for that extra level of challenge. Now I won't put these answers up on the screen, but I will give you guys some challenge problems, just in case you're looking for that extra problem. Try the same trick for 8 rolls, or 12. Pause and compute, and check how the chance creeps higher. Okay, I know, we've done some hard problems in the last 5 to 10 minutes. I want to take a break now and do a cool down puzzle. This puzzle is one of my all-time favorite math puzzles, and I can't wait to share it with you guys. So now, on this screen, I will display a set of 5 numbers. The first set we will be doing is 7, 5, 4, 9, 2. Now, this is a brain-stretching game. I'll give you 5 digits, and you have to use all of them exactly once. Plus, you're allowed to use any operations you like plus, minus, times, divide, exponents, parentheses. And your goal is to get 21. Now this is a really good brain teaser, and it might take you a second, and maybe you'll need a piece of paper and a pencil, but if you really want to challenge yourself, try to do it all in your head. But using any combination of these expressions in any order you want, try to get the number 21. You could pause here and try now. Now we'll give the second brain teaser, which is another set of these numbers. The set is 9, 8, 4, 3, 2. Now, alongside these numbers, I will put a set of solutions as well. The way I chose personally to do this, but there is a large number of ways to do this. And I really hope you guys enjoyed the lesson today. Once again, I'm really sorry I was not able to make it on Sunday. And I hope that next year I'll have an opportunity to teach you guys again. If you guys like this video, I have another really similar video ready, or lesson for cards, and also talking about probability and somewhat relating it back to statistics. But if you guys want to hear that lesson, please reach out to me and let me know. Thank you so much.